Hello, my name is Mr. Asprey and this is my video on how to use the Casio 991ex Class Whiz and the Casio CG50 graphical calculator in statistics A-level exams. Now all the questions I'm going to go over are from past Edexcel questions and they focus on the four main topics: correlation, data, binomial, normal, and these are the topics which you need to know how to use the statistical aspects of your calculators. Now I'm going to start with the Class Whiz and then I'm going to move on to the CG50, and you can navigate through using the chapters in the video to look at the parts which suit you or the calculator that you have. I hope you find it useful. If you do, please like and subscribe. Let's get into the maths. Let's do this. Okay, first question, and we have got a we need to work out the product moment correlation coefficient. So I'll go into my calculator and I would press menu, and I'll go to statistics, and then I'll go to option number 2 for y is equal to a plus bx, and then I would type in all my numbers. So I would go 3, 6, 8, 7, 5, and then I'll go all the way down, all the way to the bottom, which I'll just skip up. Okay, so I've just put in all the 16 for the x, and then I would go up to the top, and I would start putting them in for the y. So 7, 7, 4, 4, 6, 8, all the way down to the bottom. And now I've just done that, I can then go and press option, and I can do regression calculate, and this gives me my R value. So I can write that out as R is equal to minus 0.5446, let's say. Okay, perfect. And then what I could also do is, if I was asked to work out the regression line, then I could just write that y is equal to a, which would be 7.55, plus bx, so minus 0.339x. And then if I was given a coordinate or an x value, let's say of 12, then I might be able to work out the corresponding y by subbing into the regression line. Perfect. Okay, next question, and I'm going to do part B here because this is the calculator part of the question, and I'm been asked to work out the mean and the standard deviation. So I'm going to go to menu, statistics, I'm going to press one variable, and I'm going to have to go to shift setup and go down to where it says statistics number 3, and I've got to turn the frequency on. Okay, so now I can put in my x values, which are the midpoints, so 2.5, 6.5, and let's say maybe I didn't know what this midpoint was, so I could do 8 plus 11 divided by 2, and that'll put it in there for me, 11.5 and 13. And then I could go, if I press down, it takes me back to the top, which is quite helpful. And then the frequencies are 12, 6, 8, 3, and 2. Perfect. And then I press option, and I want one variable calc, so number 3. And there are all of my important bits of data. So I was looking for the mean, which is x bar, which is 6.63 to 3 significant figures. So I could write x bar is equal to 6.63. And in fact, actually, technically this is y bar because the variable here is y. and we're also asking for the standard deviation. And in this case, we use where it says sigma x, so that's 3.69. So we say sigma y is equal to 3.69. And we are done. Okay, now we're looking at the binomial distribution. So on my calculator, I would go into Menu and Distribution. And for the first one, I want x equal to something, so I just need binomial PD. So I press number 4. I just want a variable, and I would do x equals 3. The number of trials is 15 from the question, and the probability is 0.48 from the question. Press execute, and I get my probability. So I write 0.0197. Okay, now the next probability is slightly tricky to find, and that's because this calculator does only do cumulative probability less than or equal to. So I need to do a little bit of a rearrangement, because if I've got probability of x is greater than 5 or equal to 5, then this is the same as 1 minus, well, what are all of the numbers which are not greater than or equal to 5? Well, it's 4 and less. So we need 1 minus the probability that x is less than or equal to 4. Okay, so now I can do, in the cumulative distribution part, I can do 4 as my x value, and the number of trials and probability stay the same. And that gives me 0.0799. And then when I do that calculation, I would have to go back into run matrix, and I would press 1 minus 0.0799, and I would get a probability of 0.9201. Okay, next question, and we have a hypothesis test, and we will start off by writing down the hypotheses. So H0 we have is equal to the probability, which is 10% or 0.1, and H1, because we are told that there has been a change, non-specific, we have to say P does not equal to 0.1. Okay, next we're asked to find the critical region of a two-tailed test of the null hypothesis. You should state the probability of rejection each tail, which should be less than 0.25. So what we need to do is find the values which give me, in the cumulative binomial distribution, so here C, D, and variable, I need to look for the probability that x is less than or equal to a value which is going to give me a probability that's going to be less than 2.5%. So essentially I'm just going to use trial and error, and I'm going to start off with let's say, well, 10% of a random sample of 50 is 5. So that's what we would expect. So let's go lower than that. Let's go 2. And the number of people is 50, and the probability is 0.1. Okay, and what I would do is I'd write that down. So the probability that x is less than or equal to 2 is 0.11. 112 technically. Okay, so that's no good. We'll go back and we'll try 1, and that is still too small, or too large, should I say. That's 0.0 338, and we want it less than 2.5%. So the last one I'll try will just be x is equal to 0 essentially. I can still use my cumulative probability to do that. I just press 0, and that looks good. That's 0.00515, which is definitely less than 2.5%. Okay, so that means that this is part of the critical region. Next, I need to test the upper tail, which is a little bit more tricky. Okay, so I need something in the right-hand tail, so greater than, which is going to give me a probability of less than 0.25. But the calculator only does less than, so I need to rearrange this. So I'll need to do 1 minus x is less than b minus 1, because this gives me all of the values which are greater than or equal to b. So the opposite of that is all the values which are just 1 less than b or smaller than that. Okay, let me just move that over. Yeah, and then we can rearrange this, and we would end up with this on this side, and this is 0.975 on that side. So we've just got to find the first value, which gives me a probability of greater than 9.75. So I go to the calculator and I try, for example, 8. That's not big enough. So I try 9, and that is above. So that means that this value in here is 9, which means that b minus 1 equals 9, so b is equal to 10. So my critical region is that x equals 0, union with x is greater than or equal to 10. Okay, now we're looking at the normal distribution, and it says that 1% of females in the country are shorter than k centimeters. So the probability that x is less than k is equal to 0.01. So because we're trying to work out a value as opposed to a probability, we can go to menu, distribution, inverse normal is number 3. The area we're looking at is 0.1. and the sigma value is 6.1, and the mu value is like that, and this tells you the answer, which is k is equal to 152.3. Now let's say that the question was slightly different, and it said the probability that x was greater than k, or let's use a different letter, let's say n, it was equal to 0.01. Well, you'd have to think about what that looked like, because your calculator will only go to the left. So if you want an area of 0.01 here, then that's the same as having an area of 0.99 to the left. So the calculation you'd have to do would be an area of 0.99, and that will give you an n value of 180.7. Okay. Next, we're asked to work out the proportion of females in the country between those two heights. Well, what we're going to have to do is go to the distribution, and that's normal CD, and it gives us a lower and an upper bound, so we can just type in 150, 175, and keep the same standard deviation and the same mean, and that will give you an answer of 0.915. So this is 0.915. Perfect. Okay, we've got another normal question here, and we are asked to find the expected number of batteries that have a lifetime of more than 160 hours, and X is normally distributed with a mean of 150 and a standard deviation of 25. So what we'll need to do here is go into the normal again and type normal CD, and we want the lower, it's more than, so we want the lower to be 160, and the upper we just choose some arbitrary large number. And if we were doing it the other way round, we would choose for the lower an arbitrary large negative number. But here we're going to choose a large positive number for the upper. The standard deviation is 25 and the mean is 150. And this gives us a probability of 0.3457, and it says a box contains 12 batteries, so we want to know how many we expect, so we times that number by 12 and we get an answer of 4.13. And yes, expectation can have decimals, even though in reality you're only going to get a whole number of batteries. Okay, next, the lifetime of batteries sold by company Y are normally distributed with mean 160 hours, and 80% of these batteries have a lifetime of less than 180 hours. So find the standard deviation. Okay, so at the moment we know that Y is normally distributed with 160, but we don't know what the standard deviation is. So we're going to have to use a Z distribution, which is normally distributed 0 and 1. We draw a little distribution like this, and what we do know is that 80% of these batteries have a lifetime less than 180 hours. So we draw a line here and we write 180 here, and we know that this area here is 0.8, 80%. And what we need to do is find the corresponding Z value. Okay, so we go to our calculator and we press menu and we go into distribution again and we go to inverse normal. We want the area to be 0.8 because it's to the left and it's 80%, and we want the standard deviation to be 1 and the mean to be 0. And this gives us a Z value of 0.8416. So we write that down, 0.8416, and then we do a conversion between these two. So we say the Z is equal to X minus mu, and mu is 160, over sigma, and we know that Z is 0.8461 and X is 180, so minus 160 over sigma. So we can go into run matrix and we can do 180 minus 160 all over 0.8416, and we get our standard deviation of 23.76. Okay, this question asks us to work out the PMCC. So I would go into my calculator, I would press menu, statistics, and I would then start typing in all the data. So the first column will be my X's, so I write 3, 6, 8, 7, 5, 3, 11, 3, 4, 5, 4, 9, 7, 10, 6 and 6, and then I would go up to the top and I would do the same for the Y's, and this time I'm just going to skip past all of this to save time. So I've got down, I've put all the y's in, and now I press calc, and I press reg for regression, and I press X, and I press either of the two, it really doesn't matter. Let's go for A plus BX. And there we get our R value. So I can write down my R value now as minus 0.5446 to 4 decimal places. And if I was asked to work out the regression line, then I could say that y was equal to 7.55, and then minus 0.339x. And that's perfect. And then if I was given an additional point, for example 12, which didn't have a value, then you could predict what the value for 12 would be by just subbing it in for x and working out what the y value was. Okay, here we've got a question where we've got data and I need to work out the mean and the standard deviation. So I'm going to focus on part B because that's where I need to use my calculator. And I'm going to go to Menu, Statistics, and I am going to put in the midpoints. So 2.5, 6.5, and let's say I didn't know what the midpoint was. What I could do, I can write 8 plus 11 close brackets divided by 2, enter, and it will give me the value, and then 11.5, and then finally 13. Okay, I press down and it pops me back up to the top, and I type in my frequencies here: 12, 6, 8, 3 and 2, and then I press calc, and then I go to set, and I want to make sure that I'm doing a one variable calculation here. I want the x values to be my list 1, and I want the frequency values to be list 2. So that's perfect. If you have to change it, then you can just type in the number, I want that to be list 2, and press execute. So that's good. So now I can press 1 var, and it gives me my values. And that tells me that x bar is 6.63, but the variable used here is y, so I write y bar is 6.63. And it tells me that the standard deviation, which is sigma x, is 3.69. So I write sigma y is equal to 3.69. And that's the question done. Okay, next we have binomial distribution. And there are two ways of doing calculations on the CG50. And it really is kind of down to preference. I'm going to show you both. You could do it in statistics mode, click distribution, binomial. And in this case, because it's x equals 3, you would use PD. And you could put x is equal to 3. The number of trials in this question, there are 15. And the probability is 0.48. So you press execute and you get your probability of 0.0197. Okay, great. And the next one is a cumulative probability. So I'll go back out and I'll press distribution and I'll press binomial and I'll press CD. And I'd have to type in the numbers again. The lowest value I could possibly have is 5, and the upper value is the maximum, which is 15. And there are 15 trials, and the probability is 0.48. So I press execute, and that gives me 0.920. Okay, I'm going to show you another way of doing it, which might be you might prefer. You could go to distribution, press binomial, and you can see what tail you want. So if I press S4, it will be equal to, and I could do X is free, the number of trials is 15, and the probability is 0.48. And that will give me my first answer of 0.96. But do notice, if you do use this method, it will truncate the answer. So what you'd have to do is press Option and go across and press View, and that's where it will give you the full answer, which when rounded to 3 significant figures would actually give you a 7 at the end, not a 6. Okay, what else can I do? Well, I can do the greater than one by pressing F4. Can you see the probability is the right tail? That gives me greater than. I can just type in x equals 5 and it gives me my answer. Again, that's perfect actually. It is rounded to 3 significant figures. And yeah, we get our answer. We can also do x's in between 2 values as well, which is really helpful. Let's say you wanted to go in between 3 and 5. You could press 3 there and 5 there. And you can get your probability come out just like that. Okay, first off, this is a binomial hypothesis test question, and it's asked me to write the hypothesis. So I'll start with H0, P is equal to 0.1, because it says that 10% is the probability. And then H1 will have P does not equal 0.1, and that's because we've been asked to identify a change, which is non-specific. Okay, part B is asking me to do a hypothesis test. It says find the critical region of the hypothesis test. Okay, so again, I could do this 2 ways. I could do it in statistics mode, and I would click distribution, I would click binomial, and I would click CD, and I would type in there are well, I'd first stop in there were 50 trials and the probability is 0.1. So I'd expect there to be 5, multiplying the number of trials by the probability. So I'm going to go quite low to see if I can find a value which is less than 2.5%. So I'm going to try 2 or less, which gives me 11%. So I'll write here the probability that x is less than or equal to 2 is 0.11, and then I would try again. I would go for 1, and I would get 3%, which is still not enough. Still too much. I need less than 2.5%, so I would just go with 0. And that is small enough, so the probability that x is equal to 0 is 0.00515, which is less than 2.5%. So that means that x equals 0 is in the critical region. But of course it's a 2-tailed test, so we're going to have to check the other tail as well. So I will go back and I will go, whoops, I didn't mean to do that. We will go for the upper tail. Certainly didn't mean to do that. And we will start with, let's say 8, and with all the way up to 50. That's too much, so we'll try 9. 9 is 5%, so I'll write that down. X is greater than or equal to 9 is 0.05, blah de blah de blah. Let's say 7, 8. And then I will try 10, and I suspect this will be the one. It is just about, so x is less than or equal to 10 is equal to 0.24. 0.024, and we're good. So that means that the critical region is this and this. The other way that we could do it, which you might prefer, is in distribution. I could click binomial, and I can click less than tail, but I need 50, and I want the probability to be 0.1. And then what we can do is we can go across and we can change the probability. I want it to be 2.5%. And what it will do is it will give me the closest x value to 2.5%. So that gives you a rough idea of what it's going to be, but that's not actually going to be the value, because we know the value is x equals 0. But this will give you the closest one to 2.5%. And then what you can do after that, because you know that's pretty close, but it's not actually what you want, you could try 0, and that is what you want. And what we could do is we could go back and we could check the upper tail, like this, press execute, and again I want the probability to be 0.025, and this tells me that x is greater than 9 gives you the closest value to 2.5%, but again that's still not less than 2.5% like the question said, so I'll try one up from there, and that would be less than 2.5%, and that is why we get the answer. Okay, next we have a question on the normal distribution. We have the mean and the standard deviation, and it tells us that 1% of females are shorter than k. So the probability that x is less than k is equal to 0.01. So we can find that using our inverse normal calculation. We can go to menu, statistics, distribution, normal, inverse normal, and I want the left tail, because it says less than, to be the area of 0.01, and the standard deviation is 6.1, and the mean is 166.5. And here we go, this gives us our answer, and that is that k is equal to 152.3. If I wanted to use that in the next calculation, I can go to menu, run matrix, and then I can press this button here, vars, and I can press stat, and I can press result from the distribution, and if I press x1 inverse normal, execute, there's that value there which I can then use if I needed to. Okay, next, finding values with the normal distribution. Again, you can go to statistics mode, go to distribution, normal, and you can click CD, and here you want your values to be in between 150 and 175 with that standard deviation and that mean, and that gives you a probability of 0.9148. Now again, out of preference, you can do that in the distribution function as well. You can press normal, and you can do the in-between tail, with the lower being 150, the upper being 175, the standard deviation being 6.1, and the mean being 166.5. It gives you a nice little picture as well, and then it's really easy to change your values from there if you need to. And what else is useful is that you can change the probability. So if you want to work out where the middle 50% is of the distribution, just type in 0.5 and it will center on the middle, and it will tell you the two x values which give you the middle 50% of the data. Okay, we've got another normal distribution here, and the X variable is distributed normally, 150 with a standard deviation of 25. And we need to work out essentially the probability that a lifetime of the battery is more than 160. So we go to statistics, distribution, normal, CD, and we want the lower to be 160, and the upper we choose just like an arbitrary large number, so just like a huge positive number. And if we were doing this the other way and we were trying to work out less than 160, then we would put 160 as the upper and we would choose an arbitrary small negative number, like so. But in this case we are going greater than, so we do 160 as the lower and we do an arbitrary large number as the upper. Sigma we use 25 and mu we use 150. And this gives us a probability of 0.34457, and we're looking for the expectation when there are 12 different trials, so we times by 12, and this will give us an answer of 4.13. And expectation can be a decimal, even though in reality we are going to have a whole number of batteries, but the expectation will be given as a decimal. Okay, next part, it tells us that we have a different distribution now. Y is normally distributed and we have the mean, but we're missing the standard deviation. So this calls for a Z value. So I'm going to need Z is normally distributed 0 and 1. And I'm going to draw a little distribution table here because it really helps. And then I'm going to read the information that we have. And that says that 80% of the batteries have a lifetime of less than 180 hours. So I draw a line in here and I write 180 here. And this is my area, which I know is 0.8 or 80%. So I need to find the corresponding Z value which has an area to the left of 80%. So I go back and I go to distribution, normal, inverse normal. I want it to be to the left at 80%. I could do to the right at 20% if I so wished. Be the same thing. The standard deviation is 1 and the mean is 0. And this gives us a Z value of 0.841. Okay, so I've got my Z value and I can use the formula that Z is equal to X minus mu over sigma. So the Z value is 0.841. The X value is 180 minus mu, the mean is 160 over sigma. So I can rearrange for sigma by going into our matrix, and I can do 180 minus 160, and I can get fancy and I can press vars stat x, result distribution, the inverse normal from the calculation I've just done, press execute, and I get 23.8. Bosh, done. If that was useful, like and subscribe. Bye for now.